So yeah, we'll start now. I think they'll join in the middle. All right. So everyone, welcome. Thank you for coming in. So we are going to start the first meetup of Silicon Sundays, and our inaugural speaker is Orhun Parmaksız. I'm sure most of you know him. So thank you for coming in, Orhun. Thank you for your time. Please introduce yourself a bit.
Yeah, thanks for making these meetups. First of all, I think it's very important to bring the embedded Rust people together and just have nice discussions and conversations around embedded Rust. So yeah, my name is Orhun Parmaksız. I am, I guess you could say, the creator or like the lead maintainer. I'm just responsible for Ratatui, let's put it that way. And today I'm going to give you guys a little update talk on Are we embedded yet? And we're going to talk about a year of embedded Ratatouille and embedded Rust. So let's get right into it. And of course, you can ask questions at the end if you have any. But yeah, this is the part 2 of Are we embedded yet? Like I said, I am an open source Rust developer. I'm the lead maintainer of Ratatouille. I maintain some packages for Arch Linux, and that's what I do on the side. And I recently joined JetBrains as a Rust developer advocate. I have a YouTube channel, and you can follow me there, and also GitHub. I live stream most of my stuff there as well. So yeah. So first of all, there's a decade-old question that we asked ourselves, asked among us as developers, and this is one of the fun questions in the tech scene. Can it run Doom? And we have tried to answer this question in many ways. We tried to run Doom on many different hardware. Here you can see like a old telephone screen display just running Doom, and people were able to run it on many different devices, little displays to the big displays, and it proved to be some really cool challenge that we just put ourselves in as engineers. And similarly to that, we asked another question: can we run a Ratatouille on embedded hardware? And this is from this screenshot is from a talk called "Are we embedded yet?" and it's from Yagoda, one of co-maintainers of Ratatouille, and she basically talked about her experiments in running Ratatouille on embedded and just trying embedded Rust in a different way, using a terminal UI library and so on. And 1 year later, I can definitely say that we are embedded. And today I'm going to talk about how and why, basically. So there's this project called Mousefood, and this talk is basically mainly going to be about Mousefood. So before I dive into that and also the technical details, let's talk about Ratatouille, because I'm sure that people are here that they might not know about Ratatouille. So it's a Rust library for cooking up terminal user interfaces. We call them TUIs. And it was forked from TUI-RS repository in 2023. We have a bunch of contributors and a bunch of companies that use it, and a bunch of open source projects as well. And it's an immediate mode, declarative, and backend agnostic library. And I will get more into details as we talk about how we're gonna port it to embedded. But that's just the overall details. And you might be asking, what does a TUI look like? Well, here we have an example. It's called this project is called a patent, and it's an interactive UI for searching projects. So it's one of there are like tons of tools out there, but this is a good one that really fits our like the showcase criteria, and it kind of looks cool. So I just wanted to showcase this one. Basically, you can have lists, you can have panels, some kind of input, interactive UI elements in the terminal, and a TUI is basically a composed widgets in the terminal, and Ratatui is providing those widgets for you. And if you want to build a Ratatouille application, it's quite simple. The flow is basically you have some events and you update the state based on those events, and state updates the UI, and then you repeat the whole process. So everything usually runs in a loop, and to start this Ratatouille application, you need a terminal object, and Ratatouille run method gives you this terminal, and then in a loop you basically draw the UI, and UI is, again, it's based on the state, and then you can read some events, and then you kind of repeat the whole process. So if you run this code, you'll only see just a text in a terminal window, and if you press something, you'll exit. And that's the whole, like, the life cycle of a TUI application. Based on this minimal model, you can have very different architectures. You can have message passing, you can have like a bunch of other things based on your structure of the Rust application. So what kind of architecture do we have in Ratatouille? It has some widgets, and the most important part is, I think, the backends. For this talk, especially because we will use backends extensively for building very different applications. So widgets describe the interface, and backends decide where the interface should appear. And you can create your own widgets and also your own backend, and those are just the traits that you can use in Rust. And that's the whole architecture, and this is something that we have introduced in the latest minor version, 0.30, and I'll get to that, why we introduced this separation between the core and other things. So I talked about backend briefly, and what does it actually involve? To implement this trait, you need to provide these methods, and these methods are basically the things that you need to render a terminal UI. So the draw method, for example, is just takes some cells and then kind of like paints some things on this area, this available area, and the rest of the methods are also just related to drawing the UI and also handling the cursor and so on. So this backend trait, you could think it of as a interface. It defines where you're gonna render your widgets. So yeah, we have one trait to rule them all. If you implement this trait, you can basically render on any display, basically. And also it includes the terminal, the GPU, web, and embedded displays, which is the one that we're going to focus today. So we have a bunch of custom backends. We have Mousefood, I'm going to talk about today. We have Ratatouille, we have WGPU, eGUI, Bevy, and then also the web one, which is called Ratzilla. And there are like more stuff coming out, and it's quite simple to implement these backends. So you could also implement your own backend. You have this, kind of like a display somewhere that you want to render terminally wise. So it's quite easy. So the terminal is actually just one rendering target of Ratatouille. It's the default one because we started this project as a terminal UI library, but nowadays it's actually is able to render on many different platforms. And we call this thing Ratatouille. It means to put a Ratatouille interface somewhere it was never expected. And we actually ran a challenge, I think 1 year ago or something, that we wanted to just challenge people to do the most unexpected thing, and we have some results, and I'll show you those projects as well. So what is Mousefood, and why are we talking about it, and why is it important for embedded? Well, Mousefood is a no-std Ratatui backend for embedded graphics. So embedded graphics is a library that enables you to render things on displays using Rust. So any compatible draw target is compatible with Mousefood. So if you can render to a display using embedded graphics, you can basically use Mousefood on top of it, and then you can render TUIs. And it supports many different, let me say it doesn't not supports, but it is tested on these devices. So ESP32, RP2040, RP2350, STM32, and the others. So we have actually tested this on these devices, but it is able to run on many more. So yeah, we have some kind of Unicode things happening, and also we support color themes and fonts and cursor and blinking as well. So we have a bunch of features in there, but Mousefood is, in a nutshell, it's a library for using embedded graphics alongside with Ratatui and render terminal UIs on embedded. So how it works is basically the life cycle of the TUI app is quite similar, but the only thing that is different is how we render the TUI, how we render it on a draw target from embedded graphics. So we have some kind of conversions happening. We have some kind of font handling, but basically we take the UI, we convert it to cells, and then we map it to pixels on the display, and then we flush. And this whole thing is quite similar to how we render in a terminal as well. The setup is also quite simple. Like, this is like very similar to what you would have in a usual Ratatouille app. You basically need a draw target, and this comes from the Rust driver for the specific screen. And you usually have libraries for these. For example, let's go to maybe SSD 1350. I don't know if you see my screen right now. Probably not. 1 second. Okay. Wait, let me just reshare my screen. So this is how you usually have these kind of like display drivers. So this is for SSD 1315, and the display target that I mentioned is basically this line here. So this line here creates a display, and you basically take that, like the rest, like the before this, you initialize the display with the pins and the other configuration, and after you have this display, you can basically map it to the Ratatouille app using Mousefood. So that's how it works. Let's go back to the slide. Okay. So after that, you create a embedded backend, and embedded backend comes from Mousefood, and then you create the terminal. So you can think it as something that wraps the draw target, and then the embedded backend, and then the terminal, and then once you have the terminal, you can render TUIs as usual. So the rest is basically the same. So you have a loop, and then you can render widgets and do the usual things that you do in a Ratatouille app. One little detail, how we handle Unicode in embedded, because we usually have these Unicode characters while we are rendering terminal UIs, and these helping us to basically have these widgets. So once you if you want to have a box in the terminal, you need to use the Unicode characters like the the box driven characters to be able to render a box that is like connected on the corners. So we need to do the same thing on embedded. So what we did is we created a custom Unicode fonts library for this. We used to use this library that is called IBM 437. It had these these characters available. We could have borders, but many widgets were not able to use this because they use like special Unicode characters. So we created embedded graphics Unicode fonts, and this is something that is derived from some font collection, and it has all the box-driven characters, all the Braille characters, symbols, and all the things that you would need to render tweets. And you can see the contents of this font pack here. Compared to just IBM 437, this Unicode fonts is way larger, and it contains all the characters that you need on an embedded display to render tweets. So after a year, what happened? Well, we had before we had a proof of concept. We had STD dependent Ratatui, and it was kind of like an experimental thing. And now we have actually no STD support in Ratatui, which means Mousefood is also no STD, and Mousefood became a part of the Ratatui organization, so we are maintaining it alongside with the creators of the library. And we support like multiple display families, MCUs. We have the themes, the cursor support. We have blinking cursor, an optional frame buffer, and we have a simulator with documented examples and so on. So it's more of a full-fledged embedded Rust plus a TUI library now. It's now being used in many projects. So I talked about NoSTD briefly, just to come back to that, what happened in that space. So we needed NoSTD because STD is fine and all, but it's usually an issue when it comes to embedded. You don't usually have the STD frameworks for the MCUs that you want to run embedded Rust. So we had to the no-brainer thing to do was just make Ratatouille NoSTD. So what we did was we actually split Ratatouille into multiple parts, including the core, widgets, backends, and macros, and we replaced the unnecessary STD usage with core and alloc crates. In case you don't know, those are just like the they're also part of the Rust ecosystem, but they allow you to not depend on the platform-specific features. So you just depend on the core library of Rust. And then we had to change the backend a little bit to make it not depend on a STD error type. We just did some more things related to the features that depended on STD. And also, polyfills, they are usually a problem when it comes to STD. So it took some time and some work to get there, but eventually we have completed the NoSTD version of Ratatouille, and now it's able to run on NoSTD. So Mousefood today it looks like this. This is the simulator, by the way. If you don't have a microcontroller yet, or if you just want to try it out how it looks like, you can just run it as a STL app, which is like a desktop application, and it just runs fine, and you can just test things out there. We have the simulator, we have ESP32 example, we have the ESP32 with no STD example. We have one embassy example, STM32, RP2040, and more are coming. So we usually ask people to submit PRs to add their example code to the repository once they build something. So more examples are coming, so it will be more like documented. So yeah, basically we have all those examples, and in case you don't have something that is not, if in case you have some board that is not covered as part of repo, that's totally fine, because only thing that changes between those MCUs is that the board setup changes, like the pins, then that's all. The Ratatouille application stays the same, and you can just use the rest of the code as usual. So yeah, let's take a look at some examples. So we have an EPD wave share e-ink screen over here. Looks quite cute, and you can basically build TUIs for these displays right now. And I will just go through some of the things. So we have this one. I actually used this tool to give a talk. It's right here, actually. I have it here. It's not on, but it's a little box that is able to render TUIs and also images. It's a slideshow tool, so I can show you. 1 second. You have to reshare, change stream. So somewhere here, I gave a talk using this little screen. So yeah, there you have it. If you are curious, you can go ahead and watch this Rust Nation talk. But here we have it. This entirely runs Ratatouille, and all the slides are also marked down as part of the firmware. So they are embedded into the firmware, and they are running it as part of the Ratatouille application. So it's also able to run their like the usual Ratatouille library, such as this one. It's called, I think, TUI syntax or something, or TUI code highlighter, something like, I don't remember, but so yeah, it's just using the usual widgets. There you have it. Some demos. So these are like I said, the usual Ratatouille widgets. So yeah. Change screen. 1 second. And as part of that talk, I also did this little cheese locator game where you have some buzzer and some little screen. And while I was making this, I was like, can I do the smallest TUI ever? And I did this TUI thing where this is just like a 72 by 40 screen, has this little screen. So yeah, you can run TUIs even on this super tiny display too. Okay, Tuitar, it's a guitar training tool that I made last year, and it is able to show you the fretboard live, like real time. So you can just plug your guitar in and see the notes. It has a couple of different modes. I have created this fretboard widget myself, by the way, so you can create usual Ratatouille widgets, and you can use them as part of your embedded application. Everything works the same, and we have some kind of a tuning and some other game modes where it's like a Guitar Hero, but a bit more like fretboard oriented. There's you can load MIDI files, and you can see the notes for those MIDI files, and you can play them by following the notes. So yeah, you can use this tool as a practice tool. So yeah, other tools for embedded work, there's ComChan for from Vaishnav here. It's a quite nice serial monitoring tool that I actually use. It's nice, and also now it has 3D telemetry support, which is crazy. So good work. Also, I've seen M2E recently for just visualizing industrial Modbus communication, live registers, and so on. So we started to have more like embedded Rust tools as this ecosystem grows, which I'm super happy about. Some other projects that I want to show you guys. This is something that was shared on X. Basically, the author said things you can do in a day using Rust, and this is in SPI display. It has some kind of like visualization, and yeah, I think this was pretty cool, but I didn't go too much into detail. So if you're curious, you can check out this link. There's Ratatui. This is basically a TUI for this Lilith Mara X espresso machine. It sends some telemetry over UART protocol, and it's just like showing the TUI for the espresso machine. So it can detect some events such as, shot, start, end, water refill, machine mode, and it's like a very nice use case for embedded Ratatui because it needs a very minimal TUI. It doesn't really need something fancy, and it's just an espresso machine. So quite lightweight, and I think it's a great execution combined with great UI. So yeah. I mentioned the Rat in the Wild challenge. So this was one of the submissions and one of the winners for that Ratatuification challenge. And this is some UI that runs on a car, on a Suzuki car, and then it's just running on a dashboard, which is quite crazy. Of course, PSP running Ratatouille, of course. And also a little game console. It's called Art36S, and it's running live input visualizer built with Ratatouille as well. And recently, there was a project called Ratatouify, and it's actually enables you to build TUIs for your bootloader, so for UEFI applications, and it's now able to you're now able to use this to build like these type of applications where you just running TUIs before your operating system boots. And this demo that you're seeing right now is called EFI MUX, and it's basically a selector for the EFI entries, I think. So yeah, that's also pretty cool. That's not embedded, but kind of on a similar vibes. So I just wanted it there. So why Ratatouille works well on embedded? So first of all, it's very minimal. So you can just reuse the widgets either on terminal or embedded. The rendering is quite predictable. You don't have many glitches as long as you have the right fonts and Unicode installed. You have the backend abstraction, and also simulation is also available for these type of Mousefood apps. And you can stay in control of many things. If you use Ratatouille, you can have very performant applications if you first of all use Rust, and also Ratatouille, so you don't actually spend many resources on your UI itself. So it's a quite great fit, and more things are coming soon for sure. Lessons learned: a small trait can unlock a large ecosystem. I'm talking about the backend trait. So if we didn't have this backend trait and it wasn't really changeable, we wouldn't have this many applications, and we wouldn't have embedded Ratatouille. So traits are an amazing thing in Rust. for sure. And NoSTD is an ecosystem work, not an attribute. So NoSTD also it has made Ratatouille something else, and also the surrounding libraries, because when you want to have NoSTD in one library, you usually depend on other libraries too. So you need NoSTD support on those as well. So NoSTD changed many surrounding libraries around Ratatouille and the Ratatouille itself, and made things even greater, I would say. So yeah, the embedded port made Ratatouille better everywhere, because we had to port some performance changes to the core library itself. So now the terminal UIs are faster too, because we wanted to have less memory usage on embedded, and it affected everywhere. Like if it affected Ratatouille itself, the surrounding libraries, and everything else around it. So yeah, it was really a good decision to have embedded Ratatouille. So shout out to Yagoda for Are we embedded yet talk, and also experimenting in the first place. So yeah, are we embedded yet? Yes, if the target can provide Rust, an allocator, a display driver, and enough cheese. But I think the better question might be, where next? So what's gonna come next? I guess we'll see together. Thank you guys. That was all.
Yes. Thank you for the talk, Orhun. It was a very wonderful talk. Uh, so, I do have a doubt myself regarding your personal thing. So, what got you into embedded? So, what made you start embedded?
Personally, I have started like many years ago with C, and back then there was like it was the really early days of Arduino boards, and we were using like chips called it was from microchip picks, and I was just interested because I just wanted to make like robots and stuff like that, and yeah, that's why. But Embedded Rust actually started with Embedded Ratatouille for me. I had some experience with embedded before, like electronics and so on. So I kind of like combined that with what I know about Ratatouille, and yeah, just kept working on other embedded things, and yeah, that's how it is. Thank you for the question.
Yeah. So the floor is open for questions if anyone wants to ask any. So you're welcome to unmute and ask any questions.
Okay, I pasted my question in the chat, but I'll read out here actually. So first, actually, thanks for such a great project. I've been using it in quite many things, and now actually it is my go-to GUI alternative. Um, First question is like Ratatouille. I see it as a very unique library. It is a widget library, and it is also a low-level rendering plus event system. Still, when I have to build new apps with it, I feel like state management, managing app layers, and these kind of things are left on the developers. There are no patterns or uh, no like helpers functions for that also. Correct me if I'm wrong, but what are your opinions on it? If this is in a vision or it belongs to a separate place?
Yeah, it's a great question. So this is something that we have left to developers on purpose, because we wanted to give like more flexibility in terms of how they want to structure their applications. And I see that this might be a little bit of a difficult thing, especially if you're like getting started with Ratatouille. You don't know how to structure your application. There isn't a clear way, clear preferred way of doing things. But this is actually the same with the rest of the Rust ecosystem as well. If you look at the Rust projects out there, it doesn't really follow like a set paradigm such as object-oriented programming. There isn't such thing in Rust. So you can use your own approach in many like projects, and I think it's a good thing. Like it gives you some flexibility and freedom, and it's the same in Ratatouille. So we try to give you as many options and as possible with the templates, and also like the documentation, and also like, I don't know, like the example projects. But yeah, that's something that we can improve on our side, but I don't think we will start showing you the way of how you should be structuring your app, or how you should have an architecture, like, you know, something that like you should definitely do. But we will try to give like more examples and like more approaches to people, such as, you know, we have the template repository, and in there we have the component template, we have the async one, and I think we want to have the Elm template at some point, like the Elm architecture template, because that's something that is also, I think, kind of popular. But we will basically have those things as part of the templates. We won't give you those things as default. So you, like, the user is expected to just decide on their requirements. So yeah, that's what I think about it. I hope it answers your question.
Yeah, it does. Actually, Elm is the latest, is what I'm right now settling on. Before that, it was just a huge mess. So, yeah, I have one more question, and this is only based on just a general curiosity I've been having. Recently, while exploring other new formed UI apps, I'm seeing many are being written in a bun, and Open2 TUI is one which distincts itself and says that and it distinguishes itself from Ratatouille with the features like alpha blending, clipping, custom rendering pipelines, and app layering, and these kind of things that they do. So, what's your opinion on, are these the objectives in the Ratatouille's vision, or also, or how do you see this distinction?
Yeah, I haven't personally experimented with OpenTui or like the bun-based TUIs yet, but I see that they are aiming for something like more like low-level control, and I think this kind of it might be close to what we might be doing, but I don't think it's the exact like we don't have the exact same vision. What we want to do instead is, Ratatouille is a widget library. It provides you some built-in widgets as default. You can compose your own widgets if you want, but what we want is basically just give you the stock ones and make the stock widgets as great as possible. So you will have like the basic controls on them. You'll be able to change the defaults and just use them as in many cases as possible. But we don't really go with the lower level approach, I would say, and we don't really plan to do that. We just want to like make the current API good enough, current widgets good enough, and make it usable and kind of make it stable, because I think that's something that we should still focus on, rather than just changing our focus to like things like the custom rendering pipelines or like widget systems. We just want to improve the widgets already, and then just see where it goes. But when it comes to Bun's approach or like OpenTUI's approach, I have seen many like other libraries that is built on top of Ratatouille that is like aiming to do similar things. So I think if you search for them, you would definitely find many Ratatouille based TUI libraries that is doing their own things, such as, you know, like declarative layouts or like, I don't know, like stateful layouts, like reactive layouts, and like, I don't know, things like the OpenTui is doing. So you can find them, but in Ratatui we don't have that in our roadmap, I would say.
Yeah, thanks. That's perfectly understandable. Yeah,
Yep.
that's it for me.
All right, thank you for the questions.
Any more questions? Yeah. Anyone's welcome to ask. No more questions, I believe. Um,
We have time. We can wait. Maybe Badr has some questions. I'm just putting you on the spot.
yeah, I mean, he did ask about embedded Rust in the start. So,
Well, I have a question for you guys. So, have you used embedded Ratatouille before, or was this talk like the introduction for you? Has anyone used it before? I know some guys have used it, but I just want to see who's using it currently.
I used it actually in an embedded ESP32 watch kind of project. But then I actually moved to an embedded graphics library, which gives a much richer GUI kind of feel. But yeah, I liked it. It probably will be useful in some other idea.
Yep. Sounds good.
use a chat also to send your answers or ask any questions. Then you don't have to unmute. So, the chat is also open. So, I'll be reading of the chat. And so, Badr doesn't have any questions at this moment. So anybody who gets questions after the stream, they are welcome to chat with Orhun in the server itself. So he's there in the embedded Rust server. So you can ask him questions there directly if anything comes up later on. So that's
Yep.
all right with you, Orhun? So I think that's about it. So we'll end the first Silicon Sundays meeting. So first off, thank you so much for taking the time to come. I'm very happy that we could have you here today. We hope to have you in more future meetings soon. If anything new is up with Mousefood or Ratatouille or something, we'd love to hear your talk on that. And also thank you for the shout out for Comchan. Uh, yeah, so we'll be having these monthly meetings. So these will be monthly, and anybody is welcome to give a talk. There are no restrictions. Okay, if anybody is interested in giving a talk, please reach out to me or Astra Kernel. Okay, and we'll set up a timing for you guys. All right. So
Thanks for having me.
sure. So I'll be floating up a form. So anybody who's interested in giving a talk can fill it up, or you can just reach out to me or Ashraka. So thank you so much for coming. Please expect the recording on YouTube tomorrow, and we'll end today's meeting. So good night and all the best.
Take care, guys.
Thanks.
Bye.
Bye.
Bye.